Okay, good morning, everybody. Welcome again. So the traditional questions are the question, do you hear my voice and do you see the slides?
Yes, we can both.
Okay. Thank you very much, Marek. Okay, so the subject for today, as you see on the first slide, are again web services. Okay, so we'll talk about more or less the same subject. Mostly recent few words again about XML-based web services. And I will try to show you that it is quite easy to use them if you have not already used them. Okay. So we finished the last lecture trying to compare SOAP and REST. And as you have noticed probably during the last week that they are on one hand quite similar. Okay, so they use HTTP or HTTPS, a communication protocol that allows to solve many problems that were noticed or before, I mean, in protocols that were used or were popular before, like, for example, CORBA. Endpoints, I mean, what is run, which method is called, okay, and how we are doing the connections between the endpoint and the real method in a given class I will show you today are more or less similar, but there are big differences, okay? Because in SOAP we have the path and the rest information is included inside the SOAP data header, okay, or data body really. In REST, it is more tricky and slightly more sophisticated in practice. So we have the path, of course, but also we have methods, okay, because we can use get, post, delete, and others, okay. And also we have a MIME type, okay, so we can describe that we want to get information in JSON format, and we are providing, if we are sending, of course, post, for example, and we are providing data in, I don't know, XML. Okay, so all elements have to match. Okay, this is sometimes a bit tricky. Arguments, so how we pass data, okay, because more or less always we are trying to do something. Okay, it's just the place, the endpoint is also a kind of the data. Okay, in SOAP, it is simple or very programmatic. We have a mapping from the arguments to XML SOAP body. In case of REST, it is more tricky. You can use different elements. You can use even the path as an element of argument. Okay, so a part of the HTTP path could be seen, or as you notice, are really an element of an argument. So it will be converted, or it is converted into an argument of some methods called on the endpoint on the server side. In case of GET, we can use elements that are also element of the path. I mean, the question mark and all the stuff after were used in HTTP area on web browsers from the beginning, from 90s, from the previous search. And of course, like in SOAP, you can send data inside the body of the message. So in case of post, mostly you can include for anything, even CSV, anything you want. So it is very flexible, and this is of course the somehow the disadvantage of the approach. Data exchange format, again, so quite strict XML, and really not just an XML following SOAP rules. So extensive usage of XML schema. In case of REST, anything. Of course, JSON is the most popular nowadays, but you are allowed to send anything or to receive anything. When we are talking about the interface exchange, just see protocol, data exchange format, and interface exchange, the same ideas, the same general problems that were even in CORBA and even before RMIs in Java, for example. And now in SOAP, we have WSCDL, which is heavily based on XML schema. In REST, practically speaking, nothing. There are the correct answer is a lot of possible solutions. There are a lot, so they are not working to others, okay? Because we have different solutions, different languages, so they are not solving the problem in general. Because there are some solutions, of course. In practice, SOAP was widely used, okay, and supported. REST is now widely used and supported, okay, and they are the basic of microservices that I will formally introduce today. Okay, maybe it's no time to talk about my experience because I will plan to the last slides of the previous lecture. So that's all in REST? Of course not. Some elements will be discussed by me today, but of course this is a very, very broad area, and we can name a lot of acronyms, techniques that are connected with REST and used in practice. So of course microservices, but since the REST is a style, so there are thousands of extensions, modifications, etc. Just to name the most, I will say, important, or some of those I have met with me in practice. Okay, so how we can define the interface contracts. Okay, so that stuff that was done in case of SOAP by WSCDL, because it was the only solution here. Since this is the style, not the protocols, there are different solutions. Of course, we can try to use JSON schema, which is more or less similar to XML schema, but there are also some REST services based on XML schema. Why not? But as I told you, it's not widely used. API blueprint. So the biggest or the typical solution is a description, okay, written in a natural language, okay, what is possible, okay. And we have standards that came from the application called Swagger. Now it's an open API. It's nice standard because in many cases the description is generated automatically, okay, based on the code. Most of coders, at least, and me among them, we are hating to develop any documentation. On the other hand, we love to use documentation, okay, because especially in case of REST, it is really a must-on, because without it, it is hard to connect to anything outside because it lacks the built-in, already used standards. But OpenAPI could be seen as a standard. However, it's not always used. On one hand, on the other, this is not so strict, or it is impossible to generate the endpoint automatically. It's more or less designed for humans. And since the REST is very general, it is not always enough. Okay, I have some cases in my life that I was using the REST based and described by OpenAPI, and of course I needed more and more information to understand, because again, like WSCDL, it describes only syntactic elements. Okay, so the semantic is not always described, or it could be described by natural language. So somebody has to develop it. A nice approach to solve some of the problems of REST, or at least from my point of view, is a GraphQL solution, and I will say a few words on it. But depending on the case, what are you really doing? There are more and more substandards. For example, if you want to play with hypermedia, okay, anything like video or anything else, we have a set of standards. They are mentioned here. So this is the problem: how to control the different types of data going on one side to the other side. Okay. If we have a lot of data, there is a problem, amount of data sent from, especially from the REST. Okay, so there are ideas to use the patch method from HTTP, which allows to get a part of the data. Okay, not to repeat everything. So we have a patch-based semantics, so JSON patch, JSON merge patch, and of course you can use any other data formats which fits your needs. Okay, so of course I will not talk about everything. I will say a few words on GraphQL today and microservices. Maybe in the next semester, I will talk on our course. I will talk about JSON schema and OpenAPI. So one of the problem, okay, REST is nice, everybody are using, but always everywhere are some problems. And there are many problems in case when are you using REST. It could be sent as an access to a database. Okay, it doesn't have to have a database on the other side, but you are downloading some information. Okay, so especially when the end users are coming from different needs. Okay, so one of the solution is the chain of REST. Okay, you have seen it on my previous lecture. Remember that funny cartoon. Okay, so the Coyote has to do number of calls to get or to update his request. Okay, so we have 4 or 5 requests. Okay, so that case was short and just funny, so it was not very heavy. But just imagine that you are accessing some database with dozens of records inside, and you are listing them. Okay, because you need not everything, but 3 of them, or maybe 5 of them. Okay, the others needs the other element of the information. So the typical solution is that, let's say we are like in SQL, select this with asterisk, getting everything out. Okay, so we have a lot of data, so they are overfetched in the sense that that too much are sent through the network, and only few elements of them are selected by endpoint to feed their needs. Okay, of course we can solve it. We can solve it when we tied the client and the server very heavily. Okay, but then, so if we add some extra fields, some extra methods to describe what really is needed, but it results that if something new is needed, we have to add a new endpoint. Okay, so documentation becomes quite important, and since it is developed by coders, it is always outdated. Okay, so in practice, the work with REST is try and errors. Okay, we're reading documentation, sending the requests. We as coders looking at the response, thinking, and again, and suddenly, okay, we have found the solution. If not found, we are writing to the producers. Okay, it's, I mean, the endpoint, but it works if it is inside the company. It's our colleagues, or there is a big chance that we'll get a response. If it is somewhere far away from us and we are not important for them, we can never ever get a response. So this is just a reverse engineering stuff quite often. So this is very often terrible for small things, for the work inside your own application or inside the company. REST is okay, but when we want to have something very flexible, when we are as a REST provider giving something which could be used in different situations, and even situation we could not imagine. Okay, REST has a lot of problems. So there are solutions. One of them is GraphQL. This is an open source data query manipulation language. Okay, so let's say like SQL. Okay, it's totally different, of course, but it could be seen that we could select almost anything, okay, almost from the already developed apps. Okay, so this is a very nice standard that tries to solve one of the REST problems. Okay, so the idea is that it interprets strings from the client. So we are somehow formal describing what we want. Okay, so again, next protocol, next standard that tries to somehow describe what is needed from the endpoint. Okay, from the endpoint. So, and returns the data that are described by the client. Okay, I want to have these and these data, and not more. Okay? That's just enough for me. Okay, so that overfitting is thrown away. Some of the elements of my slide disappeared. Okay, so at the first line should be information that it's coming from the Facebook. And it was really first because, you know, Facebook are doing a lot of stuff and they are still doing new elements. So that problem was noticed by them soon. It was around 2012. And around 2018, it became an open standard, open organization. So now it's available for everybody. So it is not, on one hand, this is REST, okay? Because in many cases, it is sent using REST ID, okay? You are sending the data, you are getting the answer, okay? So this is REST in that sense. On the other, it is slightly different, okay? Because it is not just a REST, it's a sub-REST element. So this is not, even in practice, it's not a replacement for the REST, a kind of alternative in some cases, okay? So you can, on one hand, you can see GraphQL as a REST. Okay, on the other, you can use in your REST API some elements based on GraphQL and some other ideas. So this is nice in case of the REST, okay? And this is not a database. Even I have told this could be seen as a SQL language, but this is not a database in the sense that, okay, we're using already developed database. This is as some adds to the APIs, okay? And this does store any data, okay? This is additional layer to already used engines, databases, libraries, okay? This is just a standard that has implementation. It has some libraries, but this is not GraphQL. It's not a library as it is, okay? So it is not a GraphQL server like SQL server, okay? You are not able to buy it in the sense that you want to install, but you can implement that standard inside your software that use some databases, some storage engines, some libraries, etc. And as other stuff connected with REST, this is language independent stuff, okay? So you can use it almost anywhere. And of course, you can go further than REST, okay? In the sense of HTTP. And one of the solutions could be WebSockets, for example, or AMQP that will be introduced by me today. Okay, that element was lacking. So now from 2018, we have a GraphQL foundation. So it was designed by Facebook to reduce over and under fetching. Just we want the data that is needed, okay? So it's a set of queries, okay, that describes what should be fetched. So it describes the resulting JSON, okay. So I want that and that, nothing more, okay. And could be submitted not only one query, but I have set a set of queries, okay. So you can in one request you can get different data from different sources. So you don't have to have a lot of calls and responses. Okay, so on the left-hand side, now you can see the GraphQL statement. So this is not a JSON, as you can notice. However, it is quite similar to the JSON, okay? Because as the result, you will have JSON, okay? There are a lot of stuff there. This is not a formal course on GraphQL, okay? I'm just pointing your attention to some popular ideas available for us to solve some problems. So this is an example that shows that, let's assume that we have a large database that monitors some some places and describes the weather conditions there, okay? So assume that for my private usage, I need Atlanta, Rochester, and Beverly Hills as the places I really want to focus, and they have the IDs stated here. Okay, the weather station in Atlanta has thousands of parameters, okay, but I really want to get data like has precipitation, temperature, weather text, and type. Okay, that's all I need, not anything more. So I'm listing it, okay? And you can see this is somehow similar to the JSON, okay? To JSON stuff, so because the result will be JSON. And we have data as a dictionary key and Atlanta, Rochester, Beverly Hills. Why? Because I have stated it formally, okay? It was my idea to name it like that, okay? And it's like SQL, so it selects a key location with that value, and this is not asterisk, but a set of, let's say, variables we want to get from the database. But on the other hand, could be anything, okay? And we have the solution, okay? So when you need something which is quite flexible, I mean that you are hard to imagine what will be needed for the end user, or they have really totally different needs. And it's like a database structure, okay, with a lot of data. This is something that works, is used, so people are aware of it. So it will help others to connect to your service. And if it's standard, so it's a big chance that there will be less errors. You don't have to discover your own standards. So it is recommended in many cases. But if you are using REST, you don't have to use GraphQL. And personally, I have never used it in practice. Okay, I have used it for the educational purposes, but stuff I am developing, which are mostly connected with NLP, so natural language processing, artificial intelligence, with, of course, REST endpoint, because this is a must on everywhere nowadays. The GraphQL approach was not needed. Okay, it's totally different situation. Okay, I needed something similar because I needed to describe what I want. So we have developed our own language to describe what we want to do. But since the GraphQL was not fitting our needs, it's more so just not fetching data, it's describing the process of processing text. Okay, so slightly different approach, but you have, if something like that is needed, you have it available. And of course, it's open source nowadays and well described. A lot of people are using, not everybody. I'm an example. I'm not using it. I have used it just to show you and just to know what's going on the market. Okay, so we have been talking about data formats. Okay, so in most cases, we can think that the SOAP-based web services are XML-based one. Okay, so XML schema, JXB, that kind of stuff that solves the problem. REST, very often, even in that cousin of REST, okay, like GraphQL could be seen, we are using JSON. But both of them are text-based, and they have a big problems inside. I'm still fighting with the problem of data formats because when, for example, XML and JSON for me are more or less the same. They have some differences. JSON is more popular among computer engineers nowadays. That's the difference I see now. But both of them are text-based one, and when you want to send a large number of data, huge matrices, okay, I'm doing, I told you, artificial intelligence. So a lot of stuff I'm doing is, for example, clustering, grouping. So it is based on the similarity. So I have a large square array, okay, large 20,000 per 20,000. Okay, so if I will save it like in XML on JSON stuff, wow, it's terrible. Then I have to upload it and parse it. And it takes ages, okay? I'm wasting time just to play with formats. I'm not only my time, my private, I'm wasting the time of the CPU time, okay? Problems with memory, etc. So I really think that especially REST allows you to use anything else. What needs, for example, quite often nowadays, I'm using JSON line, okay? So JSON with each statement, each object in separate line, and it speeds up processing. Okay, it's okay for me because JSON line is like a list. So one element of the two-dimensional array could be seen as the list. So it fits my needs, okay? But not always fits everybody's needs. But also I want you to point your attention that we have something which could be seen totally different, okay, because XML and JSON are text-based, but we have a protocol buffer solution coming from Google. So big players like Facebook, Google are using REST, of course, and they are facing the problems I'm pointing your attention to, okay? So protocol buffers is a binary format, okay? So it has its own IDL language that describes the type, so it's nice. Google assumes this is 10 times faster than JSON, okay? But I will say this is not a very big success because JSON XMLs, they are slow, okay? And the idea is quite similar to the idea coming from the XML stuff. So it automatically converts its description to classes if you need classes in languages like Java, C++, for example, or C#. Okay, so you have a language inside binary language. We have the description of the types. Okay, and they are generating types from Java to Proto standards and vice versa. So this is a very simple example from the protocol buffers 1.0. It was slightly changed, but you can see that this is the example of that ideal, that language that describes what's inside. Of course, it could be done like that using your hands, but it could be done also automatically. Okay, so because always we need to describe types somehow. Okay, so we need a language that will do that stuff to generate classes on other sides and to check if everything. Okay, you are not forced to use it in case of REST. You can do anything, but if you have any element that allows you to speed up, to check everything, is much better. Protocol buffers is not very popular. Here, when it was first introduced, I don't remember, 5, 6, 7 years ago. Time is passing very fast nowadays, so I don't remember when I have first time seen it. I was thinking, okay, this is the solution to problems. Maybe everybody will be using, but it's not true. So still we are using JSON, even if it's slow, even without JSON schema, etc. So what is my recommendation? My recommendation is use what you need, what fits your needs, okay? So quite often I'm using CSV, for example, even because it solves some problems. So it could be seen on the other hand like JSON line, okay, with separation, undefined, okay, comma separated files, quite our standard from 60s. So, and still it is REST. Okay, so the basic idea of REST and not even of SOAP was to use HTTP. So HTTP or HTTPS to solve the problem of security. But HTTP is not the best solution, or it generates a set of problems. And I think the biggest problem, which is not always happening, but sometimes, at least in stuff I am doing, it is quite common problem. It's a problem of synchronicity. So HTTP is synchronous. Okay, we are calling the server. The server is calculating. Okay, during the silence, that my server was calculating the response, and you are getting the response. Okay. Okay, it's working. But assume that sometimes you are doing long processing time stuff. Okay, my artificial intelligence sometimes is like 2 or 3 days of doing some calculation, for example, or sometimes even 2 months if you are building a deep learning based model of the Polish language. Okay, it took in our case 3 months, okay, to get the model. So sometimes it is really long time, but sometimes it's not very long time, but 10 seconds, 20 seconds. And in case of the overload, okay, you can be much longer. Okay, so then you will get a timeout, which is depending on it was 30 seconds at the beginning. Now it mostly depends on the operating system or the version of the operating system. So sometimes it is 180 seconds, but still it is 2 minutes. Okay, so still it is short time. So okay, you're opening the connection, you are giving the request, and your client, because it's mostly based on the client case, on the client operating system, on the client implementation of TCP, IP, and HTTP. After that amount of time, without not getting the response, it stops the communication. Okay, so the code gets the error response. So very often people are doing, okay, I will ask again. Like human beings, I have a case on one of my presentation of our systems many years ago, when it was the first presentations, and most of our end users are humanists, and for more than 1 hour, I was talking about some technical details. It was stupid because now I know that it was too much for them. But my main response, okay, was be patient. Okay, if you will not get the response at once, just wait, not reload. Okay, so there were 25 people in the room. I was giving in the theater room while I was giving a presentation, and then we noticed that we have more than 300 requests, okay, because people were loading the page, okay. So anywhere you have long-running services, be aware that synchronicity is a huge problem, okay. And even it's big problem when you have a fast responding services, because when something will happen, we have end of the year, financial year, and everybody are using the system. So some right time cases, and everything is not working. It's collapsing. It is a cascade of errors. So why? Because usually you are reloading the page as a human being. So you are making again a request. So and the server is doing the calculation. Okay, you have one client, but in practice you have 100 of requests. Okay, so suddenly everything is not working ever. So be careful with that. That's why there are solutions, but we have to be aware of them, of asynchronous approaches. So one of the solutions are callbacks. For example, in Java, we have a standard asynchronous server API built in JXRS. The idea is simple in general. The idea is like that the call starts something, but the response is getting by the call from the server side, but now it's a client side. Okay, but it is not a REST. It requires from you to build the client, the server specifically. Okay, so but be aware of that, especially because very often I've noticed people are not aware of it, and I'm providing my stuff to some companies, and okay, I don't know asynchronous. I need synchronous. It is okay. It is okay now, but when it will be used more, they will notice soon big problems. So how to achieve asynchronity without callbacks? Because callbacks, or building callbacks in something that by a hidden program, so it will be much easier to be deployed. There are different solutions available on the market. For example, if we want to play with the HTTP, we can use the HTTP built asynchronously based idea. I mean, WebSockets. Okay, WebSockets. That is a nice idea, but it's not very, very common. Again, I was thinking what was introduced many years ago, that it will replace anything else on the earth, but it is not true. So it means it is hard to forecast future. But WebSockets are still used, and they are not prone to that problem because they are opening the connection, okay, and they keep the connection, so it's not closed due to timeouts. The other stuff, and I am using it in practice, so that's why a few more examples I will share with you based on my experience. This is a AMQP protocol. Because this is not the only that kind of stuff protocol. The protocol connected with messages servers, but one of the most popular, okay, it has some drawbacks. It is not designed, for example, when you have something like 1 million requests per second, okay, but when you have 20,000 requests per second, it's perfect, still working. When you have something which is 200,000 requests per second, okay, it starts to be slow, okay? So, but if it's not as number of requests per second, it is perfect. And I'm using, that's why I will talk about it. But I'm not saying here this is the best or the only solution. Everything has some limits. And one of the projects I was involved in that aim to have much larger number of messages per second, we use the other solution available on the market that was able to face the problems. Always you have to define some boundaries, what a planned number of requests, etc., etc. MQP is nice, but taking into consideration not too large number of requests per second. Okay, So this is an element of the message-oriented middleware, an element of the solutions for big applications, but sometimes I'm using it in even small applications that allows you to send messages over or among applications or among endpoints, okay? It's a binary protocol, okay? So it's nice from that stuff, but very often inside MQP, I'm sending JSON, okay? It could be, of course, serialized to string, and then could be seen as a binary stuff. So binary is good in that sense that everything fits there. Of course, we have had from late 90s JMS, and it's somehow similar, but Java messages are only API, which is the API base only for Java Enterprise Edition. Now we have something that you can deploy anywhere, and you can use it in Python, in C++, and other languages. There's a lot of implementations of the standards, like StoreMQ, Apache ActiveMQ, RabbitMQ, even in case of some cloud systems that will be the subject of the next lecture, they are implementing it. So it's worth to be used in some cases, okay? So few words about it and the idea, because to understand how it works, you need to understand the idea. It's quite fast, not very, very fast, okay? So it has limits. It's developed in Erlang language, so it is the language which is aimed to have a number 1 million of threads, okay, inside. So with light threads, not heavy threads like in Java, for example, have. So that's why they are using Erlang inside. It's based on the ideas of brokers. Okay, so we have brokers, that's RabbitMQ servers, and the brokers, you can have one broker or different brokers. It's not a problem, and brokers could communicate each other. So the clients see the other clients as they were in one network. And the idea is that we have connections. Okay, so connections between broker and the client, for example. We have channels. So in one connection, there could be a set of channels. Channels could have names, but could be also without names. And we have queues. Okay, so queues are for endpoints mostly, and the client could connect to the queue, for example, to the named queue, etc. What is nice that you have clients implementations in most of nowadays used languages, so you can build a client in any language, and it solves the problem of asynchronicity because it is aimed to deal with the messages asynchronous way of communication. Okay, so what are possible schemas of communication that you can achieve using that kind of approaches? Okay, so the most typical case when that stuff is needed is the producer and consumer problem. Okay, so we want to send data from the producer to one consumer, many consumers. Okay, so the idea is simple. We are sending a message to the exchange. The queue is connected, is bind to the exchange, and the consumer binds to the queue. Okay, they have names. Okay, so I want to have some information, and they are sent asynchronously without. So they are sent, and if consumers exist, they are getting the data. Okay. It could be more sophisticated in practice. We have 3 different approaches. Okay, so we have a direct approach. Okay, so I mean that a queue is connected directly by the binding key, by the name. Let's say it is possible that we have different queues with some additional elements in the name. It could be seen as a routing pattern. So we have topics. Okay, and one topics are going to the Q2, the others to Q3, depending on some selector. And we have idea of the funnel, so it's sent everywhere, okay, to everything, and it could be collected or not. So it is quite flexible. Of course, it does not solve anything available on the earth, all problems, but the problems that have messages, asynchronous communications, it is quite nice. it has some problems. The main problem could be seen here because it is centralized, for example. Okay, so we have brokers. And sometimes this is a weak point of the system. So how to achieve a point-to-point communication asynchronous, and this is the code in Python. Okay, so I want to send the data, just anything. Okay, body could be anything, string, but of course any binary data, but of course any JSON, for example, can serialize to JSON. So I'm making a connection. Okay, I'm creating a queue, and I'm sending the data, publishing it. That's all, asynchronous. And the client, if it wants to get it, he or she are getting it, and that's all. If more data, they are stored inside the system. Okay, so even you have a permanent store if you want. If there will be a downtime, the data could be stored on the hard disk, and then it's slower, everything in memory, but there are such solutions. Okay, and this is the example of the client, which is asynchronous. Okay, because this is asynchronous communication, so it's based on callbacks. Okay, so we have a callback that that gets the body. Okay, so we have the body. The body is the body that we send there. Okay, and also there are headers, properties, so we can add some extra information to it. Of course, we can connect everything. So again, we are connecting to the server, the name, IPs, ports, passwords, etc., which are not shown here for simplicity. We are getting the channel, and we are attaching the queue at the end. Okay, and consume. So we are stating that on the end of that queue will be a callback that is defined here, and that's all. Asynchronous communication. Nice. Just notice how short the code is, and it's working. Of course, you can do it in any other language you like it. Sometimes we need an RPC call. Okay, so we need only not to send the data from the client to the server, but we want also to get a response. Okay, so like a normal call in programming environment. Okay, remote procedure call. The task we are trying to solve somehow during our lectures. Okay, Corba, SOAP, REST, and now I don't know if you will send JSON. It could be seen as a REST, but it is. On the other noise TTB base. Okay, so how it's solved? By two queues. The idea is that the client creates creating the request. He creates the temporary queue for the answer. Okay, so that queue usually has a stupid AMQ something name in the system, and you have the server that gets the replies. Okay, so when it's finished, that queue is removed. Okay, so the client sends the data, then waits somehow. So now the client becomes the server in that sense that the client waits for the response. So when you have client-server communication, you could have RPC just doing that stuff twice. Okay, so it's nice and it's working. Okay, the code is much longer or slightly longer because we have consumers on both sides in practice. Okay. But also, if you want to have a blocking code in the sense that your code is waiting for the response, it is possible. There are already developed stuff that allows you to wait. So endpoints in the sense of REST are defined by queues. That's all. Now you have something like REST, but in different environment with queues inside, and it's working perfectly. And what is nice that we could have different servers connected to the same queue. Okay, so now you have a kind of a load balancer, just multiplying servers, just running a next server. That system will work as a load balance systems just for free. Okay, how to multiply a server? It's easy when we have cloud ideas, when we have virtualization. So it will be the subject of the next lecture. But in practice nowadays, it will be probably done using them. Using the ideas of Dockers, okay? For example, Kubernetes, and in 2 weeks it will be described by me. So all stuff connects together to build big reliable, fast responding system. Okay, and the client has call, okay, and waits for the response. Of course, it could be done in a synchronous way of coding, etc. Depends what you really need. So what's also a nice, okay, I have lost one of my slides. I don't know why. Okay, so give me a second. I will show you it in the practice. Maybe one of the, but what is nice, okay, I have to share the screen. Give me a second. Okay, so all my days, each morning and evening, I'm just looking here if everything. So for me, the nice element of the RabbitMQ is that I have a free, because given to me from RabbitMQ user interface. I could see what's going on with my system. Okay, so you can see how many of services I am managing, and most of them. And I also see, okay, the system is not used. The queues are empty. They are not used. Maybe I will run something that will show that the system is alive. Okay. So I'm giving some requests, and you can notice some additional queues are stored here. Okay, so something is going on. I could see if I got responses. Okay, so it's running. That stuff got some elements. I see how many requests per second are there, when it's connected, etc. You can notice that some of them. Okay, so a lot of them, and you can notice that I have not one consumer, one server. I have 30 servers, even using Kubernetes that will be shown by me in 2 weeks. I could automatically enlarge the number of consumers because it is used and it's not used. They will downgrade to use the resources in a proper way. So if it's not needed, it will be not available, etc. So really that MQP or other similar solution could be also seen as a kind of the REST protocol, okay? But I have replaced it with a different approaches. So this is nice, and we think about the REST. It's very flexible. But remember, asynchronous approaches sometimes, not always, but this case I'm dealing with is important, and one of the solutions MQP. Okay, so how to develop web service. Okay, this is the example from late 90s. Okay, this is the example from Axis 1.0 and Java, a terrible language which I loved. Okay, maybe past tense. Now I'm mostly writing codes in Python, but I still think Java is a nice language for educational purposes. Axis is old-fashioned, not used, etc. But why I'm showing it? Because all details could be seen here. I will soon show you how it's done in Java and modern solutions, more modern solutions, and you don't have to do anything. But here you can notice all the details. That's why I want to focus you what's going there behind. Inside, okay, because it will glue with my slides that was shown last week. So WSCDL, how to get the WSCDL? It's easy. When you have a server, just add question mark and that 3 letters, and you will get the WSCDL file. Okay, I hope that you remember a week ago I was showing the same information, that WSCDL file connected with some adding purposes. Okay, so I have that stuff. Then I'm running the converter, which is available when you will install the Axis 1. Okay, now you don't have it, it's done automatically, but let's hear all the steps had past tense to be done by humans, okay, by hand. Okay, so now I'm converting that code. So the service self-described, you have some language, XML heavy based, and now you are converting it into the class file automatically. So as the result, you will get a list of 5 Java files, which names math are coming and coming back from that names, math, this is the name of the endpoint. Okay, so, and the service locator, and the most interested for you as a coder is a math interface. Okay, because math interface, okay, you can see this is what is really needed for a coder. So the name, so the name of the method, arguments, xy. Why it's at, why it's xy, you can notice. It was stated here in that funny, ugly, very flexible XML schema approach. Okay, and now just like normal programming, okay, in normal programming, you can play with new and classes, and you can play with factories, similar to the factories idea. Okay, so you are getting the locator, you are getting the object that implements the service, and just like normal local programming at. Okay, so strictly speaking, to use a SOAP-based server, it's like normal programming. Okay, some small extra stuff have to be done like that. Okay, but it's generated automatically. Okay, so it is there is no difference between local programming and the remote programming. Okay, there are differences. You have different types of exceptions generated here, connected with progress, with communication. So it's always so simple? Not. You have to imagine, or you have to notice, or I hope that you are aware of the fact that sometimes we are not using so simple things as was shown before. What I mean by the word simple, we have XY, built-in types, doubles exist everywhere, maybe not everywhere, but in most programming languages. So if you have more sophisticated data and more structured data, you have some extra additional classes, okay? So not only those 4 I mentioned before, but some classes that are representing the data structure. So for example, when we have such description in the WSCDL, what is phone? Phone is area code, which is integer, and exchange, which is string. Okay, so magically, after that compiler, automatically such class will be available for you. It is nice because get area code, set area code, so somebody is familiar with Java coding, setters, getters, is their life. So it's again like normal programming. And what is nice, the data structures, the types are going through the network automatically, in the sense that on the endpoint, a PHP code could be. And that example you have here was prepared by me when at the endpoint was in PHP. Okay, I was programming in PHP, but it was 22 or 3 years ago, so many years ago. Okay, maybe web server is hard to be developed. Wow. Okay, you need a Tomcat server, which is an element of the Java Enterprise Edition ideas. But then you are just doing the stuff, making a class, okay, that does the stuff, adds something. Now, slightly different example, adding integers, and that's all. You don't have to generate that WSCDL ugly stuff by hand. It's done automatically, okay? It's done. That's all. The library, the Axis library does it for you. Okay, but nobody is using Axis today. But now you can notice that all the elements there. So how it is done today or for the last 15 years in Java, we have the library called JXWS, so web services, the name is coming from. And to develop a service is like local programming, and just you have to add that magic annotation. Add web service, and that's all. And when you have a Tomcat or that kind of providers, okay, services, servers, you have just to mount it, run it, and that's all, okay? And it's available and you can access it, or if it's in local programming, just somehow connect, inform the user how to use it. And then you can call it and get the WSCDL to connect to it. It's not a problem. So just class, add web services, and you can connect to it from the other side without any problem. So it's simple. It's like normal local programming. You don't have, okay, there are libraries, there are magic behind it, but it is simple. Maybe it is hard in Microsoft stuff, okay, which I even hate more than Java nowadays, okay, but I was using it many times, okay. So again, even in that environment, it is simple, okay. So if you want to build a client that will, for example, connect with that stuff developed in Java, you need to get a WSCDL, convert WSCDL to DLLs, okay, because this is Microsoft, okay, their own format, and that's all. And you can just remember that add that I was showing in Java. Now you have the interface inside the representations of that add generated from the WSCDL in C#. Okay, so you have name, you have the class, you have attributes, return values, and you could call it just like normal programming. So it's simple everywhere. Maybe it's hard to build a web service. It's easy. You can use Visual Studio, click, and you will get the template, okay, that you have to fill. That's all, okay? So you have, again, some annotations, but in Microsoft style, not Java 1 style, but the idea is the same. Annotations, okay, and just normal methods that will be exposing their capabilities, okay, their interface automatically in XML-based style, okay. Creating an end user, okay. So this is the code. Is server again, so web method that will, for example, do funny, stupid stuff, convert from Fahrenheit to centigrades. Information that the class is a web service class, and it's running. Okay, client, you have to get the WSCDL, convert into DLLs. Okay, it could be done using that Microsoft Visual user interface. Okay, just select proper options, then build the user interface in any way you like it. And if you want to call the service, it is simple. Just okay, you have to get that service you need, and you are calling it like a local programming. So what I really want you to inform you that is very simple. Server or the client, why it's really simple? Because the needed conversions, the needed types, or description of the types, which in the sense of C# or Java are classes or interfaces in practice, okay, but they're kind of classes, full abstract classes, are generated automatically. So just that statement will cause that it will be described using the WSCDL automatically. You don't have it to do it by hand. Then you can download it and use it because it will be converted into C#. Okay, C# and C# on both sides. Maybe this is not a very challenging task. I may be using SOAP. It's not, let's say, the fastest solution, but of course, on both sides, you can have anything, okay? So you can connect C# with Java, with anything else. So exposing some capabilities of the application for web services, it is totally simple, okay? So how it is in case of REST? Again, quite simple, but not so simple as in the previous case, okay? There are some pitfalls, but in general, it's also very simple, okay? So just recap the REST. is the idea of exposing some resources, functionalities through URIs, okay? Create, retrieve, update, delete, okay? So we are using methods from HTTP and we are transferring whatever we want, okay? Now we are free. It is an advantage or disadvantage, okay? Because we have to know what we could do. There is no general way of self-description of that formats. Okay, so technically speaking, the REST is just HTTP. Okay, so we have the name of the server. Okay, so the endpoint. We have the method, and we have the format of that meme type. Okay, so I want to get that data from that host of that format, and this is the response. But be careful because these elements are that one and that one are very, very important, and maybe that one, the three elements are important because they have to match from the client and the server. Okay. So the idea is simple in general. Okay, we have the address. Okay, example humans. We have the method, and we have the received data, the format, application XML, get, and example humans. Okay, it is not hard stuff; it's simple stuff, but sometimes is the source of problems. Okay, so how to develop something like that in Java or similar stuff in Java? Again, the approach is similar. I mean, you are creating a class, normal class in your lovely language, okay? And you are adding some information by annotations, okay? But here, since you need to be careful with matching, okay? Because you have at the end, as always in programming, a method, okay? Get customer resource. So when or how the method could be called, how to call it, how you have to use a given protocol, given method, sorry, a given endpoint, and a given representation. Okay, so by annotations, you are matching that URL-based stuff to the Java or whatever other stuff. Okay, so it's done in case of a JXRS library, now RS, okay, because REST, using at first the path annotation. Okay, the path means the path, okay, so customers. Okay, so if the server and the class is registered in the application which is named REST app, okay, so the endpointing server registers applications with names. Classes could be prefixed with any paths. Could be, you could state just no path here, but if you want to have different classes, that paths could be important because the server has to know which class has to be called, which method has to be called. Okay, so customer/1 matches the path or customers, so that class is selected. And here you can notice with some additional brackets that this is argument. Okay, so anything that will go here after the customers, after the slash, will go here. And what is nice, that it could be treated as an argument, and do the other annotation at path param, okay, that annotation allows to match that one to that integer. Okay, so at first the path defines the class or element of the path. At second, it defines the method, and on the third, it includes also some argument that is passed to the method. Okay, so path is full of everything. Okay, with endpoints definition, with values. Okay, so you have to be careful because everything has to match. There's nothing stated about get, post, about the meme type yet. So now that class will work for anything because I have not stated it is get. If we are not stating something, it means anything. But of course, you can do more. Okay, so for example, annotation post means that that stuff here, that start task, is available through post. So only post methods will go there. It is available under name start task. So if you will call it from the, I don't know, maybe shell script or wget statements, okay? If you will misspell, you will have a not found resource error. More consumes and produces, okay? Because we, as you can notice here, we can state what we want to get. Okay, we are not stating here what we send because this is get. In case of get, the information, no extra information, I mean the body in HTTP is not existing because get is without a body, okay? But now I have the post. So if I will be calling it and I want to be sure that that method is called, I have to use post. The path has to be start task. The meme type for the consuming has to be set to application XML no, the input application XML and the output, so it expects the text plain situation. Okay, and just notice I have here the other method with different name because in programming the names, okay, they don't have to be different in general, of course, because we have overloading. But let's say they are different, and just notice that these annotations differ slightly. Okay, so now I have the same start task, okay, the same producing type, but it differs in input media types. Now it's form well encoded, so this is the standard which is used by form tag inside HTML. Okay, so probably it is designed to play with HTTP-based user interface. Okay, not interface based on JavaScript and XML HTTP request. Okay, so remember that, of course, these annotations have to differ somehow, because if you will have exactly the same statements, then you will have a side effect. You will don't know what will be called. But if you want to be sure what is called, the path, the method, consumes and produces has to match. Okay, because it's not so simple as it is in case of JSON, in case of web services based on SOAP. Now you have more flexibility, so you have to take care on details. Okay, be careful because everything has to match. The other example, what I really wanted to state here, give me, okay, how to inform, for example, the end user that something was wrong. You know that in HTTP we have status. Okay, so okay, I mean 200, but if you want to inform the endpoint that something wrong happened, okay, for example, the status bad request, it is possible. I'm sending the response which is called bad request, and this is an okay statement. Okay, so I'm creating a text plain element. Okay, so unfortunately, in case of REST, there are a lot of details you have to take care of. Okay, maybe it is hard in C#. It's similar, so simple and similar approach. Okay, so so you have to prepare the endpoints. So again, annotations, service contract, operation contract. So now get the template, some elements included inside the path. Okay, so it will be available here. Maybe string is from the small letter because C#, no Java, and annotations now not at, but other character is used, but idea is the same. But even more, you can notice here that it could be really sophisticated, that some elements are constants, okay, that one in red, and some elements are variables, and it could be done. Okay, so this is the example of the C# interface for the robot, really, in practice. So I was moving the robot. I was selecting which engine has to be moved and where. Okay. So how to delete a server? Server is, of course, an implementation of that interface. Okay, this is the interface. Sorry, not that direction. I have to implement it and run it. Okay, so this is, I'm accessing the service to give a URI, and that's all. Okay, I needed an implementation, but the implementation is not important for you now because there were some technical details how to access the real hardware. Okay. Client. Okay, if the client is in C#, it is simple because there are tricks in C# how to access data interfaces. So when I will send that interface to the endpoint, it is easy. I could use it like that. But without that interface, interface, okay, and that interface is not generated automatically from Java, for example, because it is the C# interface. It will be not generated automatically from the Python because this is C#. Okay, so this is the problem in case of REST, that if you are making connections among different words, you can develop that interface from scratch from the description of the endpoint. Okay, it is possible, but always include some human being involvement, which is prone to errors. This is the weakest point of the REST. Originally, 15 years ago, even REST services were assumed to be running as an element of heavy servers. IIS, for example, some kind of Tomcats or WebSphere, for example, very large applications, heavy in the sense of the usage of CPU, etc. But soon, let's say 10 years ago, libraries became popular that allows you to add such capabilities to any code, to standard edition of Java, just to C# applications running from the command line. Okay, so in case of Java, the library is called Jersey, for example, and you are just creating the REST service was shown by me, attaching it to the server. That's all. Now it's running. But other languages like Python also gives you such capabilities, and is again quite similar and quite easy to be run. One of very popular solution, especially for built-in systems, that kind of stuff. Okay, so for simple things, like could not be heavy overloaded. Okay, this is the problem. A CherryPy, for example. But what I really want you to pay attention, I'm not saying that CherryPy is the best, it's not the best. Sometimes it's the fastest, but I want to mention this is very similar. Okay, so we are making a class. This is the server. We are making some methods, and we are exposing them. Okay, here I am exposing them. That method will be exposed or available from the other side. Okay, and I could do some stuff inside. Okay, and I'm creating a server, and I'm accessing. Okay, I'm stating that application, okay, will be used that class, and that's all, and it fits together. Of course, in case of Python, we have other solutions. In case of typical REST applications, Flask is quite popular. Also, more or less the same idea in general, CherryPy for business systems. Okay, so maybe a much better example of CherryPy with colors now. Okay, so the most simple idea, just and it's working. More sophisticated idea. I want to communicate using input JSON. Okay, so I'm informing that the input data, so that input data will be JSON. Okay, so now the request, which is representing the object that represents the request coming from HTTP, it has a field JSON. You can just read it and you have a JSON type. Okay. If you want to send the resulting data as a JSON, again, annotation, different, of course, in CherryPy, different in Python, and in Java, different in C#, but idea is the same. Informing by annotations stating the matching. So, for example, the meme type, okay, different, but idea is the same. And I'm returning the dictionary, which automatically is converted into JSON. So it is for beginners. It is nice. Maybe it's not very fast. Okay. Me personally, in case of Python, I really prefer the asynchronous approaches, which has some advantages. Asynchronous programming, and especially I think they are quite nice for web services. Okay, but of course it requires to understand how asynchronous ideas works. So statements like asyncs in Python, and this is not my aim to let's say involve you in that area or to describe in details, but just notice that the approach is quite similar. Okay, I mean the other library, asynchronous one, and asynchronous programming, it's really worth to be used, I think, but I'm creating an object, a method. Okay, it could be a class, of course, and the method in the class that does something. Input is the request, so object representing whatever is coming to you from the HTTP word. Okay, and I'm creating the response and doing some stuff inside. Okay, so it's normal programming, okay, but with some additional stuff. I'm creating a server. Of course, I have to match. Matching is important. I have to match the path to the method. Okay, the path to the method, and I'm doing the stuff here. So if it will be called without any address, it will go to handle with some information. It will be sent to handle, and that information, that element of the address, because it's only get, so nothing else could be sent, will be named a name, and this is the way how could I access the name. Okay, I'm getting it with some default value and running. And I have a small web service. I have a small REST service doing simple things as a separate process. Okay, that two elements are important for next slides. If I want using that Python stuff to deal with JSON, which is the most popular, okay, so I'm creating a handler. Okay, it has a request as an argument. Now, a case when we are dealing with classes, okay, and I'm getting the JSON. Okay, I wait because it's asynchronous programming. I'm getting some other data, and I'm producing the response. Okay, and now, and before and after really in the code, I have to connect that method with the endpoint. So the name of the HTTP method, the path, and the pointer, okay, of the method that will be called. So local programming, it could be asynchronous, synchronous, Python, Java, C#, whatever you like, whatever you love, whatever you know. Okay. Normal programming, some extra annotations joining the path to real code, you can pass some arguments, okay, like data. You can pass arguments like it was shown before. Without a path, and you can return whatever you like, whatever you want. For example, text, if you want. And it's working. Simple, easy, available everywhere. Small things, large things. Python with Java, no problem. Java with C#, no problem. So just assume that in your group there are guys who knows Java, the other guys knows Python, and suddenly you have to do something for tomorrow. Okay, it's not a problem. You don't have to learn Java, or they don't have to learn Python. We can communicate each other using such simple things. Okay, we can pass arguments. Okay, so this is the other example, but you just notice this is Python, but very similar idea. Okay, using the same notations, that this is the argument, and you can access the argument here. So it leads us to the end of our today lecture and to the idea of microservices. Okay, these techniques allow us to achieve such solutions. Okay, so microservices architecture, introduced around 2010, now becomes let's say a must on. Almost everybody is using it. I'm not saying this is the best solution on the earth and solving all the problems, and sometimes maybe monolithic architectures are still nice. But due to techniques I have shown you on previous slides, the availability of REST APIs and to develop them, it is so simple that that's like normal programming. Such stuff is possible and is used. So it could be seen as a variant of service-oriented architecture. Okay, so we have loosely coupled services interconnecting each other. Originally, in SOA, that services were rather connected with something which could be seen from the business point of view. So they were in granularity quite large. Okay, so 2 or 3 per application. Now they are of any granularity. It could be even so simple as it was shown by me on previous slide, just 3-4 lines of code, if it is needed, of course. And they are separate processes. This is quite important. Why it's nice to have elements of your applications as separate processes? Because for testing and developing, it's faster. Why it's faster? Just imagine you have a very sophisticated business application that composed of 1,000 of elements, okay? And they are not yet developed. You are developing them. And one of the components is new, so you have to test it. So, okay, you are making some local tests, then you are plugging the component to the system. Oh my God, exception, everything crashed. Okay, so what to do? I have to stop the process, or maybe it stopped automatically. I have to change that line of the code, compile again, run the system again, wait 10 minutes to run it. When it runs, oh my God, next line is wrong. What a stupid guy developed that code, okay? We are becoming nervous. And now just opposite situation, we have microservice architecture. So all that classes, all that are exposed by services, they are run separately. So if you will get some problems here, you are just stopping that stuff, that simple, small stuff, or large, sophisticated stuff, depends what are you doing. And getting new code, improving the code, and running, but running only that stuff. So the problem that is local is not exposing to others. Okay, nice, working. I want to run it. Okay, there are a lot of services. I'm out of memory. I'm out of CPU, whatever. What to do? Wow, I need to buy a new. It's easy to get a new hardware nowadays due to virtualization. That will be the next subject. Okay, but how to move one application on different servers if they are not designed like that? Well, it's hard. sometimes possible, sometimes not. Now it's easy. I could move that account service to a new host, and it goes through internet, just connections, just TCP/IP. It could be on the other side of the earth, okay? But when we have a connection, it works. So even for one host system, it is easier to test, run, and modify when it's decomposed into smaller elements. And also other problems. I want to develop something that is designed for mobile application. So maybe it would be nice if guys from mobile application will be doing, okay, they are, I don't know, Kotlin guys, okay, they know Kotlin. So maybe it would be nice if they would develop the server side also in Kotlin, okay? Here I have guys that are working with HTML, so they are JavaScript guys. So maybe it will be nice if they will develop the server side also in JavaScript language, Node.js. Okay, not a problem. So Java-based code, JavaScript-based code, I don't know, Python-based code, C#-based code, C++-based code, everything works together. People with different backgrounds, sometimes libraries are better in a given language, some in the other. I have say a few words about my background, artificial intelligence, okay? So we have libraries nice in Java, the others are in Python, the others are in Julia, for example. And that solution, simple solution, allows me to solve the problem because I'm exposing the capabilities as a REST services in different languages, different processes. It works together. That's communication, okay? So originally, the big systems were monolithic, okay? They were composed of different elements, but they were running as, I don't know, Java Enterprise Edition server. Now they are decomposed into components, separate components. It could be running in different languages, different environments, and just that funny, simple REST or similar things allows us to communicate them inside. Okay. Originally, web services were designed for communication between such systems. Now we are using the communication inside, and decomposing gives you a lot of possibilities. Of course, decomposing is not only possible due to libraries, REST, but also due to some hardware stuff. I mean, clouds. I mean, Dockers. Okay, and will be the next step. So the next lectures will will be talking about the same, but from the different point of view. So it's worth to have microservice architecture. It's easier to be deployed. Different techniques could be used. People with different capabilities could be used. Okay, because we have to solve the problem, and it's not the case that we have a ready team of 10 people with the same language. They know the same environment. Very often we have to mix stuff together. So these small things allow us to develop our modern application, but still we need the story to go on, since 2 more lectures from me, and the story will be about microservices again, but how they could be achieved in practice. Virtualization trick or para-virtualization or the small ideas, I mean Docker. So thank you very much for your attention, and I hope we will see each other, or we hear each other next week. Virtualization, cloud, this is the subject next week. Thank you very much.
Thank you.
Bye-bye.
Question.
Yes.
Is there a possibility for students to use some server on our university, like for project purposes?
Yes, it is, but I don't know why. Okay, the story is simple. I was providing to students some servers. We have still some of them. Yes, quite old, 10 years, but still are quite working. So I could create a virtual machine for you. This is not a problem. But I don't understand the purpose, because we have clouds and they are free for you.
Oh, we were just talking yesterday about the different projects, and we just came up with the question if there is a possibility at all.
Yes, it is. There are such possibilities, but okay, so contact by me by email. Okay, I could create a virtual machine for you. I don't know if the server is working, but at least on Tuesdays I'm at university, so I could turn it on. Okay, but you know, I still don't understand the need. Okay, because if you need Windows, you can go to Azure. If you need something else, you can go to Google. And as a student, you have an account. You have $200 or $300 for free, so it is enough for the project, and it will be maintained by much clever guys than me. Okay, so it really will be the next week's subject, but it is not a problem. If you like, just send me email. Okay.
Okay, we just got curious because we are going to use Azure, but we got
I
curious.
think it's better to use Azure. It's more okay, because behind that server university, it's me. Okay, a human being that's doing a lot of stuff. Okay, so if something will be broken, sometimes you will have to wait a day to have a result. In case of Azure, it's done by the company. Okay, so even such large companies, like Nokia, it's a huge company. Okay, but they are not running their software on their purpose. They are using their purposes for testing, developing, but then it's run, I don't know, in Ireland, for example. Right, but it's because it's cheaper. Okay, that will be the main subject of the next lecture. Everything is cheaper, but of course, if you like to try, just ask me. But I have to check if the server is really working. Okay, because I was doing such stuff you are asking for me 10 years ago, 5 years ago, but 5 years ago it stopped. Nobody asked me. Okay, so I'm surprised by the questions, but of course I could help you. Sometimes it's needed to have access physically to university purpose. Okay, especially to hardware, because it's the server is in 229 library room. Okay, I don't know if you are aware of the rooms in C3 building, but ask me, I will create you a web instance of the virtual machine. The question will be what operating systems you like. Okay, Ubuntu is okay for you?
Yes, I don't bother. We just got curious. We didn't plan to do anything, at least for now, in that regard.
But it is possible in theory and in practice. But it surprised me. It's the first question during the last 3 or 4 years. Okay, so I'm very surprised. But
okay,
I was ready for such stuff in the past, so I have just to remember the password and etc. And probably I would have an access with it. But it's without GPUs, okay? I need some, okay, let's say sometimes students ask me for GPUs because this is the stuff which is still hardly to be available for free, okay? It could be available, but it's very limited. Okay, so I'm waiting for the email, okay? Bye-bye.
thank you.